We want to differentiate y is equal to e to the 2x divided by 3x plus 1 squared. We should spot this as a quotient, and we're going to use the quotient rule. We identify the numerator u as e to the 2x and the denominator v as 3x plus 1 squared. We need du dx. Using the chain rule, differentiate e to the 2x as if 2x is just x, so we get e to the 2x, and multiply by the differential of 2x, which is 2. Tidying, this gives me 2e to the 2x. We also need to use the chain rule to find dv dx. Differentiate the bracket as if 3x plus 1 is just x, and multiply by the differential of the contents of the bracket. This tidies to 6 times 3x plus 1. So following the rule, dy dx is equal to v times du dx, which is 2e to the 2x, 3x plus 1 squared, minus u times dv dx, which is 6e to the 2x, times 3x plus 1, all divided by the v squared, and 3x plus 1 squared squared is 3x plus 1 to the power 4. We have differentiated, but we can tidy this further. If we look at the numerator, we can see a common factor of 2, a common factor of e to the 2x, and a common factor of 3x plus 1. If we open a bracket, for the first term we need another 3x plus 1, and for the second term we need a 3. The denominator is still the same, although now we can see that this 3x plus 1 can cancel with one of the ones on the bottom. So we get 2e to the 2x. The bracket becomes 3x minus 2, and the denominator is 3x plus 1 cubed.